Again, welcome to CS 102 Java Programming Language. This lectures cover chapter 5 of our course textbook. Our main objective is to go through the concept of selection statements, how we can write a Java program that can make a decision. And normally we call this selection control structures. So again, our main objective is to go through the Boolean expressions, if and if-else statement, and also the switch statements. So normally if we write a program and we want the program to make a decision, then we have to use a conditional statement or selection statement. In our previous programs, we write from chapter 1 to 4. Our program doesn't make any decisions. It just executes in linear order or in sequential order. So here we say a conditional statement. Let us choose which statement will be executed next. Again, our previous program, execution takes place from up, down, straightforward, linearly. So these are sometimes called the selection statements. And before we can write a condition in Java, we need to know what is called the Boolean expressions. So almost every programming language uses the relational operators. The relational operators here are the equal to, not equal, less than, greater than, less than or equal, greater than or equal. There's no space between the two, again, operators. Now in Java, one equal sign means we assign a value to a variable. So we call it assignment. Now equal, we have to use two equal symbols or assignments, no space between. So that's what to say. We should know the difference between equality operator, which is two equal signs, and also the assignment operator. So a Boolean expression normally have two outputs or two results. When we have a condition, either the condition is true or false. That's why we call it a Boolean expressions. So again, we are going to use those operators, relational operators, to construct a condition. So this is an example here for if statement. Now here we are saying that if the sum, so the sum will be a variable, and maybe we have a value in, and also we have a mass also will be a variable. Normally by convention, a mass will be a constant variable. So normally constant variable, the name is in uppercase. So here we are saying that if the value in the sum variable is greater than the value in the mass variable, then we are going to perform this operation. We are going to subtract mass from the sum, and we assign the result to data variable. Now, if the sum value is low or lower than the mass, then we are going to skip this statement. So again, greater than is the relational operator. The condition here also is called the Boolean expression because we have only two options. Either the condition is true or is false. So here we say first the condition is evaluated, then the value of sum is either greater than the value of mass or not. If it's greater than, then we are going to execute our statement, which means the condition is again true. If it's less than, the condition is false, we skip the statement. We are not going to execute it. So let's see an example in a program called age.java. So in this program, we have our scanner class because we are going to get an input. Our program name is age.java. So our main class is age. We have our main method. We declare a constant variable named minor and we assign 21 to it. We create our scanner object named scan. Again, I won't go through these steps no more because we have gone through all the syntax already. So here, what we are doing is that we are asking the user to enter his age. So enter your age. The user enter the age into a variable named age. Then we are going to check. So this is what we are learning today. So here we are checking if the age is less than minor. Now, minor is 21, constant variable 21. So this means if the user enter, let's say age to be 20, is 20 less than minor? Yes. So we are going to execute our first statement. Youth is a wonderful thing, enjoy. Then also we execute age is a state of mind. Now the second system.out.println doesn't affect the if statement. So it doesn't matter. Always it's going to execute whether it's true or false. So now if this condition is false, we are going to execute only the second system.out.println statement. And if it's true, we are going to execute both statements. So here, for example, we enter 47. Is 47 less than 21? No. So that's why we execute only age is a state of mind, the second statement. Next, we enter 12. Yes, is 12 less than 21? Yes. So we execute both two statements. Youth is a wonderful thing, enjoy, then age is a state of mind. So next, we need the logical operators. Normally, the relation operators, we use it to, again, construct condition, only one condition. Now, if I have a condition that I want to negate it, let's say, for example, I have a condition I will say not true, then it will be false. So the logical not operator is used to negate our condition. If the condition is true, if we say not true, it will be false. If it's false and we say not false, it will be true. Now, the next one is called the AND operator. AND operator and OR operator is called the binary operators. Normally, we use it to combine two or more conditions. Now, with the AND operator means all the conditions have to be true in order to execute the statement that follow. If one of the conditions is false, then all the conditions are false. The outcome will be false. OR means if only one of the conditions are true, then all the conditions are true. We're going to execute our statement. So let's go through what we call the truth table. So with the logical not, we said that if condition is true and we say not true, it will be false. If the condition is false and we say not false, it will be true. The next is the AND and logical operator. In Java, we use the %, as a symbol for the AND. And or we use the two vertical line. Also, the % is 2, no space between them. And let's say they are truth table. So we have two conditions. As we said, and or they are binary operators. So we need at least two conditions. So we have, let's assume A is a condition, B is a condition. So here we say if A is true and B is true, which is here, true, then we get true output, which means the statement that will follow will be executed. With OR, also the same thing. If A and B are true, then we get true output. Now, if A is true, but B is false, then the AND operator will be false. So AND only will be true when all the conditions are true. So we can see the rest for AND are false. And also with the OR, it will be only false when all the conditions are false. So if A is false and B is false, the output will be false. Otherwise, it will be true throughout. If one of them are true, then it's true output. Even if we have, for example, 20 conditions and 19 of them are false, but one is true. If we are using OR, the output will be true. So let's see example how we use them in a condition. So here we have if total is less than mass plus 5 and not found, then we are going to execute the statement that follow. And this means if our value of total is less than the mass plus 5 and also found is false. So not false is true. So that means both conditions are true, then we execute. Now, if one of the conditions is false, let's say the total is greater than mass plus 5, then we cannot execute. The condition is false, so we skip the statement. So with N, all the conditions must be true in order to execute the statement that follow. So that's what they gave us example here. Let's say total is less than mass and also found. Now, if found is false, not found will be true. But since total is less than mass is false, the output to be false. Now we find that found is true, not true is false, so the output to be false. Found is true, false, not found is true, but again, total is less than mass also is true, so the output to be true. So here we can see again, found is false, so not found is true. And total less than mass also is true, so true will give us true. Next, the found is true, not found is false, so the output to be false. Again, normally if we get only one false, we don't need to check the second one because automatically it's false. So this is again another example given us for the if statement. The syntax as we saw it earlier. We have if, then the condition. If the condition is true, the statement will execute. If the condition is false, we skip the statement. And this is the logic of the if statement. Sometimes we call it one-way if statement because we don't have the condition if it's false. And that will be the next. So here we have condition, we check if it's true, we execute our statement. If it's false, we skip. Now with Java, indentation is not important, it's irrelevant. But normally it's good to have a nice indentation of your program so that it will be more easy to read. It will be more clear and simple to read. So we have a quick check here. Here they say, what do the following statement do? We said if total not equal to stock plus warehouse, we are going to assign true to inventory error. So again, if the condition here is true, then we are going to assign true to inventory error, which means if the total value is not equal to the stock plus the warehouse, then we assign true to inventory error. So here we can see that the variable name is inventory error, which means the total is supposed to be everything we have in stock plus the warehouse. The next one also said, if found or not done, we print OK. So if found is false and not done is false, then we can print. But if one of them is true, then we can print OK. So here we say we set the Boolean variable to true if the value of total is not equal to the sum of stock and warehouse. Then here we're going to print OK if only found is true or done is false, or both of them are true, or one of them again true. So next is the two-way if-else statement. So this time, if our condition is true, we are going to execute statement 1. But if the condition is false, we are going to execute statement 2. So let's see an example in wages.java program. So here we import the number format class. We use this again to format our output. We still need our scanner class because we're going to get an input. And we are using the system.in, so we get the input from the keyboard. So here we have a variable named rate and standard. Both of them are constant variable. And the rate is 8.25. Standard is 40. We declare variable name pay. The data type is double. We assign 0.0. So next, we ask the user to enter the number of hours he worked. And if the user entered the number of hours, we are going to check if the hours is greater than the standard. Remember, the standard is given to us as 40. So the idea of this program is if a user works for 40 hours, it's not going to get overtime. But as soon as he works more than 40 hours, then he's going to get overtime, which will be after 40 hours, the next hours that come will be time and a half. So here we are calculating the overtime because the hours is greater than 40. So first of all, we are going to 40 hours will be standard time. So the rate, 40 times the rate, which is the standard rate for first 40 hours. But now the overtime Because hours is greater than 40, we subtract the 40 from hours. Again, the first 40 hours is regular time rate. Now, when we subtract the 40 hours from hours, whatever is left is time and a half. So we multiply by rate times 1.5. So that will give us the overtime and the regular time together. Otherwise, if it's false, which means user didn't work more than 40 hours, then we're going to pay him a regular pay, the hours times the rate. So this is what we are learning here, two-way. We have the if condition. If the condition is true, we pay overtime. If the condition is false, that means it didn't work overtime. So we give him a regular pay. Then here we print our statement. So we import the number format class. So we create the object name FMT for it. And you can see the output. We use fmt.formatPay because the FMT here is going to have a get currency instance. So we're going to format it in a currency. So let's see how example looks. You can see the output, the $sign come in, and 2 decimal places. The format of currency we give us. So here we can see that the user worked 6 hours overtime. So this is how the if else. We have 2 statements. The first condition is true, statement 1 will execute. If the condition is false, statement 2 will execute. The next, let's see the coin class program. So here we have a coin class. This is the main method. So let's go through the main method here. So here we create the coin object, name my coin. That means the coin class, we have a method named flip. So we flip the coin, then we print whatever we have. Now here, this is what we are learning here now. Again, when you flip a coin, you only have 2 options, either it's a head or a tail. So this flip method, we are going to see the coin class. It gives us a head or tail. So here we say, okay, if my coin dot is head, then you win, else better luck. So that means to win, you need to get head. Now to understand this, we need to go to our main coin class. So this is our coin class. Head represent 0, tails represent 1. So first we create our coin. Again, this is our coin constructor. And we're going to initialize it by calling the flip method. Why we know this is a constructor? Because as we said earlier, constructor name is the same as the class name, and it's not expecting no returning value. And normally we use the constructor to initialize the object when we create it in the main method. So this is our flip method. So we can see that our flip method will generate a random number 0 and 1. Because as we said earlier, the random method with empty argument, we generate values less than 0, greater than 0, but less than 1. Any value, again, greater than 0 and less than 1. And it's a decimal number. So even if I generate 0.999, 0.999 multiplied by 2 give me 1.88 something. Then we change it to int, so that will be 1. If I generate a number, let's say 0.02 or 0.2, again, we multiply by 2 first, then we change it to int. So the only possible number that will be generated here will be 0 and 1. Then we also have the method to check if it's head. So we assign the heads to face. So is heads return true if the condition is true. Otherwise, it will return false if this condition is false. Then we have to string method that again will represent the object. So it's string. So we have our face name. If face equal to the heads, we assign the heads to face name. Else, we assign tails to the face name. This method to string is called automatically anytime we call the system.out Total.println. So now we know how our coin class look like. We have the flip. We can check if it's head, and the flip give us 0 or 1, 0 for head, and 1 for tail. So this is the program again. We create our object, my coin. So since this object-oriented programming, coin is a class, my coin object can use all the method in the coin class. So he used the flip method to flip the coin. The output should be only 0 and 1. So we print whatever the output is. When we call the system.out.println, toString will be called automatically, and the format of toString will be printed for us. Then we check if it's head. Remember, its head will return true if it is. Otherwise, it will return false. If you return false, that means the if statement is false. So it's going to print better log next time. If you return true, it means the if statement is true. So it's going to print you win. So one thing also we should know is what we call the block statements. So in our previous conditions, we see only one statement. If I have only one statement, I don't need a curly brace or a block statement. So normally, if you have more than one statement, let's say 2, 3 or more, it's good to put everything in a curly brace, which we call the block statement. So with this block statement, if this condition is true or false, it will affect all the statements in the block. Now, if we don't have the curly brace, it will only affect the first statement. So this example again, if total is greater than mass, then we print an error, then we increment error count. Else, we print total, then we multiply total by 2, and we assign it to current. So again, this is called a block statement. If the condition is true, both two statements will execute. If it's false, the else section, both two statements will execute. So let's see an example of a program here. This program, they say, is going to demonstrate the use of block statements. So first we have our constant variable named mass. We initialize it to 10. We also have a variable named answer and also a variable named guess. We create our scanner object named scan, and we use it again, going to generate numbers or as the user to enter the numbers with scan. So we also have the random class. We're going to generate a number randomly using the generator, which is the random class object. So here we say generator.nextInt, which means we are going to generate again an integer, whole numbers. The mass is 10, we had plus. The next system.out.print, I'm thinking of a number between 1 and 10. Because again, the condition here will make it possible to generate numbers between 1 to 10. The reason why we say plus 1, because if you have 10, it will generate number between 0 to 9. We don't want to have the 0, so we say plus 1, so that it will generate from 1 to again 10. So we ask the user, now the user enter the number, guess it. So now we are checking if the number the user enter is the same as the number that was generated. So if guess is equal to answer, then we say you win or you have a good guessing. Otherwise, that's not a correct. Sorry, the number was, we tell you the number. So this is a block statement on the else section. Both two statements will execute. So here we enter 6. And that's not correct because the random number was 9. We also have what we call the nested if statement, which means if statement inside another if statement. And normally the outer statement will execute first. Then we check the condition before we check the inner. So let's see an example how they use it. So here we have a program named mean_of3.java. So again, we import the scanner class. Our main class is mean_of3. We have the main method. Again, we declare num1, num2, num3. three variables, and also mean, we initialize it to 0. We create our scan object. Then we ask the user to enter 3 integers. The user entered the 3 numbers into the variable num1, num2, num3. Then we are checking. So this is our nested if statements. So now we check if num1 is less than num2, and also num1 is less than num3. It means num1 is the minimum, else num3 will be the minimum. Then we have if num2 is less than num3, then num2 will be the minimum, else num3 again will be the minimum. So this program will print the minimum value among the 3 values we enter. So with the nested if, we check the outer first. If the condition is true, we come to the inner. If it's true, then we print. Now, if it's not true, then we're going to print the else section because the outer is already true. Now, if outer the first if was false, then we will come all the way down to the else section outside to check what to print. So yeah, that's why it's called nested loop. In order to check the inner if condition, the outer if condition must be true. If it's false, we cannot check the inner condition. So here we enter 84, 69, 90. Again, the minimum value is 69. So that will be the conclusion for these lectures, and hope to see you guys in the class. Thank you for your time.